For centuries, humanity gazed at the stars, dreaming of exploration. Now, we're not just explorers, we're prospectors in a new gold rush, not on Earth, but in space. This isn't about jewelry, it's about securing resources to fuel our future, both on Earth and beyond. Asteroids and moons promise untold wealth and opportunity. Our planet's resources are finite, but the solar system is a treasure chest. Imagine building satellites from asteroid metals, or refueling Mars missions at cosmic gas stations. Private companies and governments are racing to develop the technology to make this real. Robotic spacecraft, advanced drills, and smart navigation are already in development. The global space economy is booming, projected to reach over $1 trillion in the next decade. This new gold rush is underway, and its impact will reshape our world and our future in space. The sky is no longer just a backdrop. It's becoming our next economic frontier. The quest for space resources is one of humanity's most ambitious undertakings. The era of cosmic prospecting has begun. The future is no longer just on Earth. It's out there, waiting to be claimed. Why now? Because the cost of reaching space has plummeted. Reusable rockets from companies like SpaceX have slashed launch costs, making ambitious missions possible. Robotics and AI have advanced, enabling smart, autonomous mining spacecraft. Miniaturized satellites pack more power into smaller, cheaper packages. Demand for rare metals is soaring as we build a greener, tech-driven world. Earth's supply is limited, but asteroids offer a nearly limitless source. In situ resource utilization, using space resources where we find them, means we can create fuel and supplies off Earth. Water ice on the moon or asteroids can be turned into rocket fuel, enabling deeper space travel. Mining in space lets us build and sustain missions without hauling everything from Earth. The convergence of technology, economics, and need has made the cosmic gold rush possible. Space mining is no longer science fiction. It's the next step for humanity. The time to mine space is now. What are we after? Water tops the list, vital for life and rocket fuel. The moon's polar craters and C-type asteroids are rich in water ice. Next, metals like platinum, cobalt, and nickel, found in M-type asteroids, giant floating metal mines. A single asteroid could hold more platinum than we've ever mined on Earth. S-type asteroids, common in the inner solar system, offer silicate minerals for construction. These materials could build habitats, shield against radiation, and support large-scale space projects. 3D printing technology lets us turn mined resources directly into tools, parts, and structures in space. This self-sustaining ecosystem means we're no longer limited by what fits in a rocket. We can build what we need, where we need it, using space's own resources. The economics of space exploration are being transformed. The treasures of the solar system are within reach. The space mining race is global, led by both governments and private companies. The US leads with NASA's Artemis program and partnerships with SpaceX and Blue Origin. Moon Express targets lunar resources, while other startups push asteroid mining. China and Japan are major players. China's lunar and Mars missions map resources, and Japan's JAXA has returned asteroid samples. Japanese companies like iSpace are developing lunar landers and rovers. Europe, through the ESA, collaborates on ambitious projects like a lunar village. Luxembourg has become a legal and financial hub for space mining, attracting global investment. Public-private partnerships are the new model. Governments enable, companies innovate. NASA's CLPS program pays private firms to deliver payloads to the moon. This synergy accelerates progress and reduces costs. The new space economy is built on collaboration and bold vision. The path to space mining is tough. Costs are high, risks are huge. Robotic missions to distant asteroids require billions in investment and cutting-edge tech. One failure could bankrupt a company. Legal questions loom. Who owns space resources? International law is unclear. Some countries allow private ownership, but there's no global agreement. Space debris is a growing threat. More launches mean more junk, risking collisions. We must develop ways to track and clean up debris to keep space accessible. Despite these challenges, the rewards are immense. Space mining could provide sustainable resources for Earth and enable us to become a multi-planet species. It's a new chapter for humanity, our reach no longer limited to one world. Success will require global cooperation, innovation, and responsible stewardship. The cosmic gold rush is more than a quest for wealth. It's a quest for a new beginning. Our future is among the stars.